last of the geometric transformations. I have composition of transformations. We showed earlier that if you do double transformation where you change to standard matrices, T of A, and then you're going to do of transformation B. So you do B and then you do the transformation A. What you can do is you can just say that this is going to be B times A times X. Now notice B is first because you do the inside first. So then you do B times outside last. So that's why it's B times A. And remember, BA is not equal to AB except under certain circumstances. And so you could transform these to the transformation matrices and just multiply them together. And that's what we're going to do. So I'm going to take the good old favorite anti-clockwise or counterclockwise through pi over 2. Remember, the standard matrix for that is cosine 2 alpha, sine 2 alpha, and then it was sine 2 alpha, negative cosine 2 alpha. So that is the rotation one. For the slope, where you're doing the reflecting about a line, the line reflection. Oh, great. I did that one already. This one was the line reflection. And then the other one is the rotation. And that one is A equal to cosine theta, negative sine theta. This one's going to be sine theta, cosine theta. Double check, make sure I have these correct. Yeah, and isn't that interesting that the rotation one doesn't have the 2 alphas or 2 thetas, and these are just switched, the signs. That's really interesting. So this is your rotation about counterclockwise. And so what we're going to do is we're going to use the information. We're going to do an anti-clockwise rotation. Theta equals pi over 2. And so when I put pi over 2 in for these, I'm going to get cosine of pi over 2 is 0. Negative sine of pi over 2 is negative 1, and so on. So this is my rotation. And then for the other one, I need to find alpha. So I'm going to do that. Just remember, cosine 2 alpha is 1 minus m squared over 1 plus m squared. This is formula material. I'd give that to you on a test. And if you need it, let me know. Sine 2 alpha is 2m over 1 plus m squared. And so when I take the slope here, m equals 2 from this problem, put the 2 in for m, I'm going to get negative 3/5 for cosine 2 alpha and 4/5 for sine 2 alpha. So this here is the reflection about the line. This up here is my rotation. Now the first thing I'm going to do is the clockwise rotation, and then it's the reflection about the line. So that's why I reverse them, because I want to put B first and then put A. If you put them in reverse, they will not be the same. So make sure that you do it in the reverse order. So this is what I did first, according to the problem. That gives me my A. This is what I did second. This is what I did for b. So I put b first, and then I put a. And then when I multiply those out, this is the transformation. This is the transformation that I get. The final transformation. Now the question says, find the single transformation equivalent. So we need to recognize, what is this? So when I look at this and do the determinant of it, the determinant is negative a squared minus b squared. Oh, I'm sorry. It's negative 16/25 minus 9/25. Negative 16 minus 9 is negative 25/25. Well, there's your negative 1, right? And negative 1 determinant means that it's a line reflection. Since it's a line reflection, we need to figure out what the line is. Y equal to something times x. Now, I have been looking at this, and this bugs me, this second transformation of x equal to x. I'm not sure how they're able to say that, except maybe they're able to say that this is what I'm looking for. Okay, and this is the formula to find it. 4/5 x plus 3/5 y, and they're setting that equal to x. So 4/5 x plus 3/5 y equals x. That's the new x that I'm looking for. The transformed one is going to be my x for this final line that I'm looking for. So when I multiply everything by 5, I get 4x plus 3y equals 5x. Subtract 4x, and I'll get x equal to 3y, 3y, not 3 over y. So y is 1/3 x. And it's probably not going to surprise you if y double prime is equal to the new y. Using this part, you have 3/5 x minus 4/5 y equal to the new y. Multiply by 5. 3x minus 4y equals 5y. And then go ahead and add not 4y. This is kind of magical, actually. 3x is equal to 9y. So y is equal to 1/3 x. So in both cases, this is the line we're reflecting about. It's cool that both the x transformation gives you that and the y transformation gives you that. It's not surprising, though. So what I did is I took the first one, turned it into a transformation matrix using the formula that's appropriate, the rotation one. And then when I got that, I remembered that that's the first thing I'm going to do, so it becomes the second matrix I'm multiplying by. That's the tricky part. And then the final thing was the line. I have the m. I can find cosine 2 theta and sine 2 theta using these formulas that we're going to use a lot with this type of reflection transformation. And then once I get those values, that creates my second transformation matrix, the B. And with the B, that is the second thing we do, so it's the first matrix we multiply by. Has to be reverse order for matrices. B times A, and that'll get you your final transformation. Then they took the determinant of that to see that it was a line. They asked, what is the single transformation equivalent? It's a line, and then you just go ahead and say, well, the new x is going to be the transformation equal to x, and this is cool how this both with the y and the x work out. It's not a mystery, though. And this is it for geometric transformations. This we have one more chapter left on eigenvalues and eigenvectors.